Okay, we're here for the big finale, right? Fifth video, AppFabric 1.1 intermediate training. So far we have configured the AppFabric after we installed it, of course. We created a cache called AppFabric Demo. We did not put any regions in the cache because, like I said, the application or middleware should be smart enough to do that. We gave permission to our user account on this machine and the machine itself to the AppFabric cache, and we used PowerShell to do all that. I believe that was video 2. We went out and got the source code from the SVN. We installed, I should say attached the database, and talked about some pros and cons of different connection strings. And now we're going to wrap it up with the application. And I think before we look at the application and define our mission there, I want to point out one very important item for Visual Studio. If you attach directly to this file using your SQL Server Manager, then it's very important that just to be sure, right-click on it, go to Properties, make sure that build action is set to none and copy to output directory is set to do not copy. Otherwise, you'll get a big ugly failure to build, because and it should make sense. The SQL process locks the file because it's using it and the log file, and when Visual Studio goes to build and copy it, it can't. So if you get a build failed because it cannot copy the file, right away you know it's that database file, and it's because the build actions, remember, right click, properties, build actions, copy never, and build actions none. So let's take a look, and I'm going to clear this out, at writing an application to AppFabric. How in the world do you do that? And how, given I only had a week, can you do it in a week? Learn AppFabric, learn virtualization of some parts of AppFabric, PowerShell 2.0 and things like that. Well, it was luck that we were already working on level 3 on a training project for CSLA, which I mentioned earlier, where we could leverage, one of my least favorite words, leverage, level set being another one, where we could leverage existing work that was done into this new project to save time. So what I did was I took the database. This Rolodex SQL Express is actually the database we're using for the app Rolodex we're writing. So we had our stored procedures and various other things like that. We had already written some classes to go along with it, and before we get into them, we'll explain our mission here a little bit. But so we were able to take one of the list of value objects, a state, because countries have states. So any Rolodex, when you're putting an address in, their country, the U.S. has 50 states, and different countries have different other states. So if you simply remove the requirement for a region, if it was the parent, you could get all states, which in this case happens to be 181, which came from the AdventureWorks database when I ported some of the data over. So we're going to be using the state, the list of values, and loading those 181 values up using SQL, and do the same thing. After we load the 181 from SQL, we'll add them to the cache, to the region. We'll create a region called states, or read something like that. We'll add the objects to it, and then what we'll do is we'll fetch those objects from the cache using the data cache get object or get function to pull it out. So not too complicated. Pull 181 records while timing it from SQL, and then put them in the cache. We're not going to time that because we don't care. What we really care is we're pulling data. And then we're going to pull those same 181 objects from the cache. It pulls them out as an object with a key, value object key pair. And so we're going to have to convert them back into their native type and put them in a generic list so we can theoretically bubble them up to some GUI where we could use the binding context managers and integrated .NET data binding functions in a UI presentation layer without any problems. Now we would do it in CSLA. Given time constraints here, I have implemented some CSLA features, but you'll notice, my level 3 people will notice there's no library project, and that would be dead giveaway. That's your business objects layer. So let's look at what we do have here. We have 4 projects, one of them being the CSLA source code. I highly recommend you get Lotka's CSLA ebook series for the new 4. I've read them all now. I read the first one, I read the second one, the third, and the fourth as he wrote the series. I think they first started coming out about 2003 or something. So been working with CSLA a long time, a great product. So there will be a little CSLA in this, but let's talk about the basic projects in it. You've got basically the .dal, the .dal SQL, and the .test. The reason you see this sort of setup is that when I write applications and when I teach others to write applications, I stress the importance of a interchangeable data store technology or methodology. And what that means is if you busted it out, you've got data backend, you've got business and rules layer, and then you've got presentation layer. Now that gets complicated when you go to MVVM. If you're doing unit testing on the UI level, MVVM's great. You know, if you're not, well, I would try to convince you to rethink that decision, and then you would go with, you know, you could do WinForms, Silverlight. It really doesn't matter. That's the beauty of CSLA objects. You can write that business object layer once and be done. We here are using test layer because we can do it at a test function layer to get it out. So in order to have what I would consider a pluggable DAL, you have to have a set of rules or a set of standards that any data backend is going to guarantee the business objects it provides. And that's what this top project is for, the .dal. It contains obviously factories, but we're not going to get into those because you can look at them, read my notes, and get them. The base layer is going to contain the data transfer objects and the interfaces that are used to get data back and forth to the back-end data store. Notice I didn't say a database or anything like that. It could be Azure, it could be anything. It could be mocks, you know, objects. But what it does guarantee you is that a state province object at the data transfer layer looks like this. This is what's in it. Okay? So if no matter what your database backend is, even XML or files, you're going to get an object back that looks like this. Alright? And if you look at and notice there's country. I didn't use a country, but that'll come when I do write the business objects. But you know, given the time constraints, I haven't done that yet. You've also got the interface, right? The interface merely tells, or I shouldn't even tell, it guarantees that some level of functionality is going to be available or implemented by the concrete classes which are going to implement this interface. Okay? So no matter what data backend we use, we're going to give the ability to get the states by region, to get the states by primary key, and to apply updates to the states. And you say, whoa, LOVs don't get updated. Well, in this case, maps change, right? So role-based security, you'd certainly make sure that only people authorized to do it did it. You do that in your CSLA business objects. It has a really cool role provider in it. But the database backend needs to provide that functionality. Just because it's available here doesn't mean it's going to be available to the end user. Right? Last thing you want to do is play requirements catch up, where no one's ever going to use this, so I'm not going to put it in there, this, that, and the other, and you end up with a great big mess 6 months when the requirements change. So we have an update, and you say, well, why don't you have an insert, an add, an insert, a delete, and an update? Well, that's because CSLA, you can preserve that metastate if we go back to one of these transfer objects, by using these two fields, the isNew and the isDeleted. Those two fields, when you transfer this object around, no matter how many layers you abstract this thing, they're always going to tell you what you need to do, right? And let me give you for instance. In the update needs to be smart enough to know what to do, right? And using those two variables, we can come up with a matrix. We can say, do I need to insert the object? In which case, isDeleted would be false and isNew would be true. Do I need to update the object? In which case, isNew would be false. The primary key would be greater than 0. And the isDeleted would be false. Unless you didn't really delete stuff and you merely marked it with the flag of deleted. But for the purposes of the meta state, it would still say yes, it's deleted. Or do I do nothing? And you say, Dean, when would you ever do nothing? Well, imagine if it is new and it is deleted. What do we need to do in the database? Nothing. We never inserted it. Maybe the user created it and then said, oops, made a mistake, deleted it. It's part of some large collection that they sent for a bulk update. And so we don't do anything with that object. We set its primary key to -1 and move it on down the line. Okay. So I think I've beaten that one long enough. Then we've got, if we go in here, what I wrote specifically for this project where we're going to measure the difference in time to do certain things. We've got where we can provide a generic list of data transfer objects. Remember, I said they're defined here. The data transfer objects, regardless of what the backend data store type is, will be returned from a function called fetchAll for cache testing. Notice the difference being we don't send the region ID. We're just going to give them all to you, and they're ordered by name. Now, that's not a requirement of this function call, but something we'll do just because it's, I like to do it. So I hope that describes, at least at the base data layer, how that's done. This base level functionality and this data will be made available no matter what the backend data store is. Now in this case I chose SQL, and that is a project here, type class library. The database files I put in here for ease of deploying this to all of you, so don't worry about that. Here we have an object called state province DAL. Now if I had implemented country, I would have had a country region DAL, but we only need one for the purposes of this test because there's more states in that table than there are countries in that database. So states gives us a little more work. If we look at the state province, before we look at anything, what do we know, right? I already said that our rules were any data implementation has to implement the .dal project. So that means you're going to have to implement the interfaces. So we can guess right off the top that this state province DAL probably implements the interface state province DAL. And guess what? Ta-da, it does. You know, we can right click and implement it, which I already have, so we're not going to do it. So these three functions are real world functions being used in our other project. We don't so much care about them in this because the whole purpose of this application was to test performance on caching versus SQL. So for the purposes of talking here, I'll address perhaps the most complicated one, the update, right? These context managers, we use, everything's in a using statement, so the garbage collector cleans it up for us. These lines you see are because I use DevExpress. I own a personal license of it, all of their products, because they're superior to any of the others in my opinion. That's Infragistics, that's Component 1, all of them, and I've used them all. For my style, they pale in comparison to what you get with DevExpress. For other styles, I'm sure that they're better. That's why you see these lines and you see various pop-ups and things that you may not see on yours. The context manager is something that's coming from CSLA, right? So we're going to get that, and it helps you reuse connections, and there's a lot of things it does to make things really efficient. A lot more so than doing it yourself. And then we go through, and it's a stored procedure. And this is where I started talking about what are we going to do. Well, if it shows it's deleted, then what are the two possibilities? Well, if it's deleted and it's new, then we don't do anything, right? Because we never saved it in the database anyway. If it's deleted and it's not new, then we go through and we execute the store procedure to delete it, right? We see if anything got deleted, because concurrency, maybe someone else deleted it. We hope not, but if they did, I've got a base exception type here of data not found exception that is used in a lot of places in a lot of my projects. So, and then we reset the primary key to what? -1. And you heard me say that earlier, that if it was an object we didn't do anything to, no matter what, we set that to -1. It's just a great standard to follow. That way down the line, if for some bizarre reason in a rule check on a business object we want to disregard or don't trust the is new, we can always look at the primary key and tell. Okay, otherwise if it's new, what do we got to do? We got to insert it, right? Because you say, well, what if it's new and it's deleted? Well, we took care of that up here, right? So otherwise, if it's new, basic stuff here. The only thing that we've got to do is we've got to get our output parameter for the new primary key value, which we're using scope identity for, and we put it back in the object, because we're going to send the object they sent us back to them. Let me show you. They're sending us a data transfer object. We're sending them what? A data transfer object. It just happens to be the same one. We're going to make some changes to it. For instance, if we delete it, we hold on. Sorry about that. Phone rings, you got to roll. Okay, so anyway, we go through here and we do the updates, and we send them the object back. And if the rows, for some reason nothing happens, we throw that data not found. Again, standards. So you can imagine a scenario where MySQL or other things were used. That'd be really easy, right? You just write a new DAL MySQL and implement everything here. You can see the reference. Implement everything up here, and now you have a true pluggable data backend. Heavens knows what it'll be in 5 years. But you certainly don't want your application tied to something at a business object layer, because then, it's absolutely horrible. That's why we're transferring, about to use a buzzword, gotta hate it, the encapsulation invoke. We're using these DTO objects. So, object's an object. Okay. So that explains what the DAL is, and like I said, right here, caching only. Fetch all for caching. Ugly, 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 but written only for this cache test where we got inline SQL. No big deal here. Now another thing, I guess I should cover it, because if you don't know SQL, if you don't know CSLA, this would throw you for a loop, right? The safe data reader. In the using var equals new safe data reader, that's defined in CSLA. Awesome object. Allows you to read nulls, all kinds of things from SQL that would normally cause C# to eat itself. The safe data reader deals with very well. And here, this might be a little new in .NET 4, where you're able to actually get typed references to things within the DTO. Not magic. Let's look here. The state province DTO, they're all public, right? So here we're able to get access to them. Okay, and then we return it, same as the other stuff. All right, so that means we've got a stable backend. We think we need to test it, and for the purposes of this mission, where we said, look, we want to be able to compare performance of SQL versus cache. And if we want to pare it down a little more in a ASP.NET application, you'd say, okay, Dean, why in the world didn't you write an ASP.NET application? Well, we don't have to. And the reason is, think about the architecture, right? Let's logically think about the architecture. You have somewhere, another buzzword, the cloud, aka a bunch of computers. You have a cloud or a cluster of computers that serve your website behind some load balancer. They are going to make a local, because remember I said AppFabric and even Couchbase, you can't go across domains and you can't go across facilities for replication. Somewhere relatively close to these machines, architecturally speaking, is going to be your cache server and is going to be your SQL. It could be another cluster. It could be an Azure cloud. You know, it could be anything. It could be data services with WCF. I mean, there's a lot of things it could be. But the reality is that wherever the code is run that's going to be interfacing this data and caching technology is going to be likely connected by wire, fiber, or some other means, even VM, you know, if it's just VM interpretations between machines, all on the same host, they're going to be there pretty close together. So in this opportunity, I said in this case, I took the opportunity to just use a test class, leverage it, that word again, from the other project, and just make some slight changes to it. The slight changes to it are up top, and this you'll see some symbols you're probably not used to because Dev Express, but test methods, I mean MS Test, it'll run this even without Dev Express. I don't have a computer without Dev Express, so everything I use, even my machine at Dell, I get these hints. So the thing I added for cache was the data cache at the class level, and then the test cache, which we use that cache utility I told you about, so we could keep one cache for this whole thing. And imagine in a website or a WCF data doling app where if you can use that one cache and not keep recreating it, keep recreating a single, you know, performance gains are, I mean, they're huge. So I tried to stick to my own rule here, where when we instantiate the class, we get the cache and keep it. So we'll reference this later, test cache. And you say, oh wait, it's null. No, remember we got the default empty where we actually assign the value. So we're alright there. Test methods above them, no big deal. Some people ask a lot about this sometimes. This dal dot, and I'll show you this data not found exception in our base, because we want everything to use it, is nothing but, you know, it's nothing but the exception, and we typed it out. So in this case, why would you want a test case to throw an exception? Well, let me lay it out like this. Remember, I said the update was this all-inclusive big thing that does your CRUDs, inserts, deletes, updates, and fake deletes, if even. So the best way to test if something really deleted is to what? Is to put the primary key of that object in some storage location, later go try to fetch it from the database, and what? The data layer guarantees us that if it doesn't find it or an operation fails, in this case the operation of the fetch, because let's say number 6, we deleted it and we go try to fetch number 6, it's not there anymore, because we did things in a standard way and in a disciplined way, it's going to throw a data not found exception if that fails. And so that's what we're relying on here. Look, in order for the test to succeed, it has to throw this type of exception somewhere inside of it. Well, somewhere inside of it being the end, because we test everything for inserts, updates, and then we delete it. And there's what I said, is we go in and we update it, and then we make sure that if it did really delete it, or I shouldn't say that, if it made it through all of the code of the delete, heavens knows databases can do very bizarre things, we set that primary key to -1, so this will be true. So we can assume, at least from a functional standpoint, we went through the motions. And then we double check that because we're a little excessive compulsive here. We go out and say, okay, fetch it. And if it should throw that exception because it's not really in the database. If it doesn't, the test fails because it didn't really delete it, even though it said it did. Okay, so let's get back to the caching. The cache performance testing, before we start drilling down into the code, it only makes sense. We talk a little bit about what we were going to do. Again, we're going to go to the database, fetch 181 objects, and we're going to measure time in milliseconds. We're going to put that data into the cache, and then we're going to get that data from the cache. In this case, we're going to put states in a states region, because let's think about AppFabric. AppFabric is a cache. You can think of a cache as a great big bucket, and the region as little bitty buckets you put within the big bucket to keep some level of organization. I told you why, because they're stored as objects and keys. Data tags, I believe, is the word they like to use for it, but if you had a person who had a primary key of 1 and an order with a primary key of 1, if you didn't use regions, you couldn't have them in the same cache at the same time. And I don't know about you, but that doesn't seem very useful to me. So we're going to have a region called states, and we're going to fill it up with those 181 objects, and then we're going to use there's a function in AppFabric in the API where we can get all the objects from a region. Problem is, all of those objects from the region are going to come back as objects and not what? State data transfer objects, right? This is the object we need to send up to our GUI, state province data transfer objects, because the business object will convert that into a CSLA business object, which can use data binding in the GUI down the road. So we need to, at least from this layer, be dealing with the data transfer objects, so we'll have to cast that back. That's known as boxing. I find it a little bit, and forgive me for being a geek here, but a little bit humorous that Microsoft, upon touting .NET 2.0, hailed in an era of the destruction of the array list, because now we could do type generic lists. And now with the new AppFabric caching 1.1, we're back to doing a little bit of manual work. I can understand why you need to support other technologies, but come on, Microsoft, let us use typed objects if we're using .NET on the front end, and maybe they will someday. So we'll see that. And then what will we do? Well, we'll write the results to a file so that we can study them later, perhaps in an app or something. The easiest way to do that is use a data set serialized to XML. So we'll just put the results in a data table, add that data table to the data set, and then save that data set to the hard drive. So let's go through the code. Okay, here we create the data set, nothing in it, no tables, just an empty well, if you will. And then we create the data table called results. And then that table, we need 3 columns, one of them being the primary key. Notice we didn't set auto number or auto increment or any of that kind of stuff, because we're going to be in a for loop. If we want to run this test 100 times, we'll be in a for loop. We can just use the counter. You know, I is going to go from 0 to 99, and we'll just use that as our primary key. The next column we're going to use is, we said it was milliseconds, so the database fetch time is going to be an integer, and the next column is a cache fetch time is an integer. So if we run the test 100 times, we'll have 100 rows in this data table. The region name, we looked at the configuration, the app.config, which we haven't looked at too thoroughly yet. This probably will help you more than anything, is you can go in here and see how to do it. Your config sections, this is something I need to highlight right off the bat. Really important, this is first, right after configuration, because you're telling it you're going to have a data cache client section, and it was going to be of these types. Well, these types aren't arbitrary, right? They come from your reference, right? They come from your reference. Because when you install AppFabric, those bottom 2 features, it installed these DLLs, which is why we can build it and not throw an error. Okay, so down here we get into describing the cache more. Where is it? What's the host name? And you say, Dean, where did you get that? Well, this goes back to why I love a good XML file. Remember, we have that shared XML file instead of the SQL backend. It comes from right here. It tells you what ports, what it is, and then if there is a cache in it, what its name is, and some stuff about it. Remember, this is time till it expires. Alright, so that's there. And then we got some things here in the app settings. Imagine a scenario where you've got a test, a model, and dev environments. We can put them in here, and then I would really hope that the cache name is the same in each of them. But just in case something in your development process went wacko and they're not, here we can tell it what the actual name of the cache is. And then here I can imagine as this was scaled up, you would want to be able to have some control at a configuration level over what regions you create in your cache. In this case, your state cache region is going to be known as states region, right? Okay. So, and then connection strings, database connection strings, there should be nothing new there for you. So we're going to go back in here, and we're going to get the settings for the state cache region, because remember I said we were going to create a cache region. Then we enter this for loop, and this is how many times are we going to run the whole comparison. We're going to do it the SQL this many times and the cache this many times. And we create the row because, well, this is ADO.NET, slow, but we're not timing while we're using it, so no timers are running. So this is all free as far as statistics go. So we're going to create that data row, grab the integer primary key I was telling you about. It's going to increment each time, so you're guaranteed to be unique. And then we're going to, just to make sure, we're going to make sure that that region we're talking about isn't already in the cache, because if you add a region to the same cache with the same name, it'll throw an exception. So let's just go ahead and remove it. Doesn't hurt to remove it if it's not there. It's not going to blow up. These are housekeeping things for debug write line stuff. We're using a .NET 4 type here, the new stopwatch. We've all had to write them over and over using time spans. Well, finally, the Microsoft folk have seen fit to give us a real stopwatch object. We're going to have two. We're going to have one for the database stuff, and we're going to have one for the cache stuff. So we'll start this test by going to the database. Well, I guess first I should start here. We start this test by starting the clock for the database section of it, and then remember we're going to get a generic list of data transfer objects back from the data tier, and we're just going to say fetch all for cache testing. Well, we went through that function. It's just going to get all the states, 181 of them, put them in this generic list of results. Notice we didn't have to do any boxing. It was all typed, so there was a performance savings there. How big? Yeah, scales with the number of objects, right? And the complexity of the object graph, right? Because these could be parent objects with children. So your object graph could be states with counties with cities, right? So one object could be quite a bit of work. The graph could be big. And so that coming back as a typed object is huge. So then we're going to stop the clock timer on the database. We're going to put the elapsed time in the first column of the, okay, let me reiterate there, second column of the data row, but it's the first of the two statistic columns. A little house cleaning where we put stuff out. And then, so we're done with the database fetch for this round. Remember, we're in our first iteration through this for loop. Next thing we need to do, I said, was what? Well, we need to add what we got to the cache. Okay? And I'm doing this every time. I don't need to, but I'm doing it every time because we delete that region, right? And so we're going to add it. No clocks are running. It's not skewing the statistics in any possible way. And in fact, it may not be a bad thing to do, because if you run it 1,000 times and the thing explodes on you, you got a memory leak somewhere, right? So redoing it every time isn't necessarily a bad thing. .NET's supposed to, and especially using the using statements as we did in our data layer, supposed to guard against that in some measure, but it doesn't hurt to be too careful. So we're going to add them using this test cache. You remember it from the beginning near the constructor. We created it with null, and on the instantiation of this class, we went out and did what? We initialized it to the cache returned from the cache utility object, which is a single cache for this application. Again, trying to get every drop of performance out of this thing we can. Similar to singletons. So we go through here and we add each data transfer object to the cache. Well, in order to do that, there's several overloads to this add. The one I chose to use was, like I said, regions are nice. you need a key. Well, since we are using regions, we can use the primary key of the object itself, which is the row ID in the database. Where you would need to be really careful here is what? Well, imagine a scenario where you're adding an object you haven't yet saved to the database, right? If you add two of them, they both have a primary key of -1, and this is going to explode. You've got two new states going into the same cache before they're saved. You don't want to do that. So your business object needs to just be smart about it. And you can write some back-end stuff to help guard against it. AppFabric, it supports features called write through and read through, where it will, you write to the cache and it'll save to the database asynchronously for you. I'm an ops guy. If I get some time, believe me, it's high on my list to test this little feature out. But I have ops stuff and teams to run, so I don't have unlimited time, but maybe I'll get some. So anyway, we add it there, and then we add the object itself. This is where the dreaded back to an object type for the data transfer object happens. And then the bucket, the little bucket in the big bucket, you want to stick it in the region name. So now we clear the list because what? We're going to go out to the cache. We're going to get these back, see how long that takes, some housekeeping stuff. Here's our new stopwatch for the cache. We start the stopwatch, and we go get them from the region. So we pass it the region name, and we convert them to an array. I'm doing this to save a little bit of performance again, because what do we have to do? Well, when these things come back, if we look at this, they come back as an IEnumerable list, right? It's got a string, which is, when we put them in there, the primary key of the object, and then it's got an object, which is the actual whole object itself, right? So we don't really care about the key or the string. We care about the object, because the object is self-aware. It has its own primary key in it. So I did this so that I could come down here and iterate through it. Notice with the clock running, iterate through it, typecast those objects back to their original type, the boxing and unboxing as it would be, and add them back to that same results list. Now, I know what some of you are going to say. Holy cow, Dean, that's an unfair test. But is it really? And the reason I say that is good software design needs to provide a known type when it crosses layers. And what that means is, for the same reason that the .dal project has DTO objects which are defined and interfaces which are defined, which describe minimal functionality, and I would argue it should all be the same across any back-end data store. For that reason, we need to bubble up to the interface, or to the there will obviously be a business object between us and the interface. There could be a couple, right? If you use MVVM and you're doing unit testing on presentation layers, I mean, you're going to have another object. So we don't need to pass up these stupid enumerable lists. We need to pass up the actual typed list, because the data type should be a generic list of state province DTOs, aka results, in here. And yes, I left the timer running because this is something that's necessary. So if you think I'm being unfair for some strange reason, you could remark this out. And to be honest, I've done both to see how it goes. Now what I want to do is I want to do it on a 10,000 object graph. I'm not going to tell you how I'm going to do that because I'm going to do it later, but there's a way I can scale this by manipulating the graph. So anyway, we're going to do that, and then we're going to stop the timer once the casting is done. So now we've got the same generic list to match what we got from the database. In my mind, a fair test. So we're going to add that row to our data table so that we can write it to the disk later. And then once we're done with the number of times we told it to run, we're going to add that table to the data set. More housekeeping. And then we're going to write the XML file with the schema to, and in this case it'll go bin debug, and it'll be in the debug folder, or production, depending on what you've got this set to. With this one. So you can see I called it test results without conversion for generic list. Well, that's not right, is it? We are doing the conversion. So we'll go test results with conversion for generic list.xml, because this morning I sent out an email to all of you probably watching this. I sent out results from home. I'm interested to see what the difference is running on the Dell network. So let's see if this works. And we're going to go up here and we're going to build it. And it builds. 5 messages. I don't like having messages, but these messages are coming from the app.config. Let me close that. Notice the messages went away. It's a Visual Studio peculiar behavior. It did it in the last version too. I like all of these to be zeros because I'm a really picky coder, and I want you to be too. So let's go through it. What we're going to do, remember I said we don't want to run the whole test class because it's going to try to insert, delete, and do a whole bunch of nonsense we don't care about. In fact, you could just go in here and remark all these functions above it out. Just worry about this cache comparison testing, the cache performance testing. I'm going to click here. This is admittedly DevExpress. Here you would just right click and go to run the test. But here I don't like doing it like that. I like clicking this and debugging my test. So we're going to stand by while this runs. Test is complete. Says it passed. Okay, so what do we expect? We expect an XML file in the bin. So let's go find the bin, which I've already gone to its debug, right? So we can go down here and we should see test results. There it is. There's our XML document. This is the one from home because it came down with the version control. So let's double click this. And here is our data. And the good thing about this is if we write and I probably will using DevExpress's graphs, because devil's in the details and I'm a visual person. If we look through this, we could deserialize it the same way in a data set and then just do data binding to graphs and the X and Y axis and do some neat stuff on the DevExpress graphs. So that's why I did it like this, and I wrote the schema so we could get it back. So we can see that the test and the DB fetch time first time was 366 milliseconds. The cache fetch time was 149. So the first time there's a huge advantage to the cache, even with the boxing and unboxing, right? But what happens the second time? We get 8 and 30. Why do you think that is? Well, let's think about why these numbers are so different the second time. Let's start on the database time. Why did it drop? Well, it dropped because of what am I going to call them? Be politically correct here. It dropped because of improvements in Microsoft's SQL connection pooling, and I don't want to use the word caching, but it's pooling mechanism. Here, I'm sure the connection would have had to be created, and here, it didn't have to be created, right? And there were some other things that go on too. With the way that CSLA and its context manager works, you get a big boost here. And you notice the cache time changed too, right? Well, what did I say was the most expensive part of the cache? Well, and that's why they say if you're going to use it in a big app, use it in a singleton. Creating it initially, much the same as happened with the database. In fact, it would be really interesting to see, and this would be on a graph, what the percentage change was here and what the percentage change was here, right? Because you can say it's approximately 3 times here, and you know these two are about 3 times apart, and guess what? 8, 16, 24, they're not too far from 3 times apart here, so you might be able to start drawing some conclusions there. But if we run through this thing for those 5 times, I mean, look at them, 427, 427, 427, pretty consistent. Now, if we run it 1,000 times, which we can just go in that for loop and change the number. We'll start to see it. And so now you know, and let's go through here. You know what? I'm going to do it. I got you. We're making this video. Let's do here and do the same thing with out the boxing, and let's see if it makes a noticeable result. I'm going to comment this out, right? So it's going to mess up some of our house cleaning stuff because we use the results count, but it's not null. It was new, so they'll just be 0. So our house cleaning stuff will be wrong, but we don't care about that. We care about the XML file. So now I'm going to go in here and I'm going to rebuild it. And I need to rename my file. And was that lowercase or was that uppercase? It was uppercase. Good. So I'm going to go here and I'm going to say without conversion for generic list. Some people might ask why I don't just go up and run the test, why I build manually each time. For some bizarre reason, I have seen it where it doesn't rebuild the app. So don't fall into that trap. The easiest way not to fall into traps, do it the same way every time. Okay, unless you're doing it wrong, of course. So we're going to go here and we're going to click and we're going to run the test again. Now, we only did it 10 times. I mean, really, to compare, we do it 1,000. But let's go in here and let's look. It says it's done. So this other file should be updated. It has been. So we've got our browser here. And we're going to take it, we're going to drag it over here. And we've got without here. Oh, dadgummit. It wants to do it in the same one. Well, here we got 231 and 42 and 2 and 19. In the other one, and we'll just do the first one where it's, you know, really ugly. So 231 and 42 without, and with 366 and 149. So there's a difference, right? 366 and 149, 42. That boxing takes a little bit of time. Actually, a majority of the time. So keep that in mind. And I'm going to keep looking at ways we can try to get around that when I get some free time. So that pretty much wraps up this video. And for all intents and purposes, temporarily the series. I will be adding some stuff to the SLN, a GUI to analyze the results, because I think that we're going to be able to come to some interesting conclusions. Where should we go from here, and where should you go from here? Well, sky's kind of the limit. Well, not really. Hardware's kind of the limit. If you can get a couple of servers and actually locate your test on your desktop, on one server put the database server, and on the other server put the AppFabric server, and have the calls actually going out over the wire instead of between some VMs or whatever, in this case, same machine, you could get some really interesting results. Trust me, I know. I've been running this thing in a lab at home, and I've found that if you can go with AppFabric, you should. Database fetch times on small runs seem like a really, really good bargain. But on the back end, if it truly isn't updated much, you should cache it. Especially if that cache server's off of your database server and off of your app server in its true own environment, because you can leverage it across apps. There's a lot of things you can do. So I hope this helped. I hope you learned something. I welcome feedback. It's dean_bortel@dell.com. Feel free to shoot me an email if you've got suggestions, or send me some code if you got some something you want me to integrate. Thanks a lot and have a great day.